I would like to introduce our next talk now. We're going to talk to you about unifying your application and infrastructure observability. My name is Myrle Krantz. Bogdan Matei is a senior engineer at Grafana. I am an engineering director at Grafana. Bogdan, tell us a bit about yourself.
Okay. Hello, everybody. I am Bogdan. I am a senior engineer, as Myrle mentioned, or how I like to call it, whatever engineer, given the fact that in the past 3 years that I've been in Grafana, I've touched mostly all the products, I think. Yeah.
Yeah.
So I am based in Bucharest, in Romania, and the rush hours that we do have in Bucharest during the week makes me go back to nature every weekend. So even though I love mountains, I really do love the mountains, I still do prefer the sea. So Romania has access to the Black Sea, and I'm trying to go there every time I can. But for example, during the cold seasons, I actually cannot. Why? Well, it's cold. So what do I do during the cold seasons? Well, I just go to the Canary Islands, because who can actually decline a beautiful paragliding session above Las Palmas? What about you, Myrle?
Well, I do love the ocean, but I'm more of a mountains person. I actually grew up in Colorado. This picture here is actually, though, close to where I live in Germany. It's in the Eifel. It's a volcanic mountain region a little bit south of where I live. You can go swimming there. You can go hiking there. I love both. I love hiking and I love swimming. So we are going to talk now a little bit about some of the problems that you're trying to solve, or that we think you're trying to solve. So we all know that modern systems have a lot of moving parts. We're going to talk a little bit about what some of those moving parts are in general, and we can monitor most of them. We're going to talk a little bit about also what our existing monitoring solutions have been up until today. And but it can be easy to lose sight of the bigger picture with all of those different monitoring solutions. So we're going to show you how, with application observability, we tie it all together to you. We've also already announced application observability and Beyla. We're going to give you a little more detail on how those solutions work. Take it away, Bogdan.
Okay, so let's look a little bit over this diagram. It's a mess, right? Well, this is how a modern shopping platform actually looks like nowadays. We have tons of services. Some of them are like client-facing, for example, the front-end service. Some of them we can consider them like middleware services, for example, the API, the services layer that is not directly exposed to the public, and also external systems like storage, caching, queuing mechanisms, and so on. Besides those, well, we do have Kubernetes, and we do have Google Cloud, and we do have AWS maybe. We have programming languages, we have .NET, we have JavaScript, we have Rust, and so on and so forth. All those services are interconnected between themselves through various request types. Some of them are based on HTTP. Well, this is easy. Some of them are gRPC. Okay, still easy. Some of them are TCP-based. A little bit complicated, but others are totally proprietary protocols that it's not super easy to analyze. So now, in this mess, developers should actually develop new feature. And how is it performing? I just released my new feature. Is it a bottleneck? Is it creating any problems in other services? How is it performing actually? And you may say, okay, but this is why we have observability. That's true. This is why we have observability. But until now, we only had infrastructure observability. And we could say that, okay, this service is taking around this amount of RAM memory, and it consumes that many CPUs, and so on and so forth. But that does not help us. So let's have a look a little bit over how observability actually look in, how instrumentations, what types of instrumentations we currently have in Grafana Cloud. So we talked about Faro earlier, which is totally automatic instrumentation. What does that mean? Well, you just add a code snippet and you deploy it, and that's about it. You get logs, you get traces, you get metrics, everything out of the box. But for the services that we don't have automatic instrumentation, for some of them we have integrations. And integrations are pretty similar to the automatic instrumentations, but they are not. Why? Because, for example, the Go integration it's not does not have the same mechanism to implement like the JVM one. And for example, what do we do with the services that are written in Java? We don't want to look over the JVM metrics, and that Java application is not written with Spring Boot. Well, for that particular case, we do rely on manual instrumentation. That means, well, we have a Prometheus client, we are actually generating some manual metrics, and then we have a Prometheus metric scraper, and so on and so forth. And we need to do this for logs, and we need to do this for traces. This is not scalable. Well, this is really not scalable, and let's see why. Okay, this slide right here has around 20 dashboards. And those 20 dashboards are the number of dashboards, is the number of dashboards brought to us only and only by integrations. Besides integrations, I mentioned manual instrumentation. And that means even more dashboards. Those dashboards are not interconnected between them, meaning they cannot, for example, I cannot go to one of the dashboards, select my, let's say, Kubernetes cluster, and then go to one other dashboard and have the same Kubernetes cluster selected there, and so on and so forth. This is pretty complicated, and it's not a desirable experience, but does it have to be like that? I mean, what if we can, for example, generate metrics out of traces? What if we can, for example, rely on open source technologies that will allow us not to be vendor locked in? Myrle, what can you tell us?
Well, if you have an amazing developer working for you like Bogdan and the rest of the team, then you can put together this solution. We've got application observability that we just announced in the keynote. This is our opinionated, out-of-the-box experience designed to minimize your mean time to resolution for modern, complex application problems. This is to accelerate your time to value with an out-of-the-box dashboards rather than dashboards you have to create, out-of-the-box workflows rather than workflows you have to memorize or understand. We are unifying your metrics, your logs, and your traces across the software stack so that you can navigate between them easily. And we're doing this while avoiding vendor lock-in because we're using the best OpenTelemetry and Prometheus native solution. I'm going to put this in the context of a little bit of Grafana Labs history. When we first started, roughly 10 years ago, we were focused primarily on Grafana. This was our big tent phase of the company. We made it possible to visualize hundreds of data sources behind a single pane of glass. In the next act, we added our observability backends, where we have cost-effective, highly scalable solutions, all of them open source. Mimir is the best backend for Prometheus metrics with hundreds of millions of active series. You can save more than a year of storage you can save in it. Loki takes that Prometheus-like approach and applies it to logs in order to reach very large scales. We see people using this to replace traditional aggregation solutions. Because of the indexing overhead, the Loki is much faster. With Tempo, it's also a Prometheus-like approach where we use the same approach in order to save trace requests across the components of your distributed systems. Pyroscope is the newest addition to our family of open source backends. Pyroscope makes it possible to profile your applications and discover your performance bottlenecks, whether that's CPU or memory. In addition to this, we have an ingestion pipeline that is also open source based around the Grafana agent. The Grafana agent does data collection based on open standards like OpenTelemetry and Prometheus. This also reduces vendor lock-in. You own your data. You should have the control over it and make use of it for your use cases. And built on top of all of this, we offer you our Act 3 solutions. We've offered already performance testing, infrastructure observability, incident response management, and now we are adding application observability to the set of Act 3 solutions. And application observability includes front-end observability. It includes the back-end observability where you can see the service maps. And also we are offering instrumentation around eBPF. So I'm going to dig in a little bit more specifically on the ingestion pipeline part of this. This is a bit more technical, the approach. So the Grafana agent you can use in order to bring the data into Mimir, Tempo, and Loki. The Grafana agent can receive data in the OTLP format from either directly from your OpenTelemetry instrumentation or from the OpenTelemetry collector. You can also send Prometheus metrics to the Grafana agent. You can send logs directly from your log sources to the Grafana agent. And you can send OTLP directly to the OpenTelemetry gateway. Once that data is in your backend, in the Mimir, Tempo, and Loki, then we visualize that data from the application observability solution so that you can see the views that we want to show you in our next step in the demo. Bogdan, I noticed during the keynote, there seemed to be some services down. They seem to be having a high rate of errors.
Oh.
We should probably check into that.
I mean, you just said that I'm a good developer. Okay. All righty. Let's see. Okay. I'm gonna go back to application observability and see exactly what you observed earlier. Okay. Indeed, there are a couple of services that do show some elevated error rates. Are you particularly interested in any of those?
Yeah, the cart service. That's a little scary because that's where our customers spend their money.
Oh, that's true. That's true. Let's head into this service overview right here and see exactly what we can find out. So, okay.
How's the duration on their request doing?
Okay, no. So basically the duration, most of the services are actually taking under 64 milliseconds to complete. And there are a couple of services indeed that do take around 1 second, but mainly this is okay. So this ain't the problem.
The errors there seem to be some errors in there.
Okay, indeed, there are some errors in the operations, but before jumping into the operations, let's look a little bit and see if we impact any services. So, okay, look, so the checkout service, another critical service, it's actually right now affected by this, and the upstream panel can tell us this. The downstream and the databases panel actually doesn't show anything, so most probably this operation can be problematic. Let's jump into it. Alrighty, so red metrics, they indeed show an elevated error rate. The duration distribution panel looks pretty interesting. So basically most of the requests that were taking 1 second earlier are coming for this particular operation. Let's jump into the traces and see what we can find out. So, I hate TraceQL. Okay, let me actually filter a little bit the spans and just find the ones that do contain errors. And I think we're good to go. Let's see. Alrighty. Okay, I'm gonna expand this a little bit. Okay, so Myrle, do you remember that I told you earlier that the checkout service is also affected by the cart service? Look here that indeed we can confirm that operations coming from checkout service to the cart service are actually failing. So both services are failing right now.
So why is the empty cart service failing though?
Well, let's see. So events and exception and, oh, there you go. So basically, I think we have a problem with Redis. And let me jump to the logs because, okay. Alrighty, so indeed, there is a problem with Redis, and for this particular service, I'm gonna call Tom and see, okay, not the CTO, the other Tom. I mean, Tom, the CTO, I mean, he can actually fix this,
He probably
right?
can, but we should talk to the other Tom first.
But should he?
No.
Okay, so basically, let's get back to the service inventory. Are you interested in any other service here?
Yeah, I noticed the front end is having a pretty high rate of errors there. Maybe not quite as bad as a cart service, but still.
I mean, yeah, also 1 second duration, that's a little bit much. Okay, let's see what's wrong with this one. Alrighty, so error rate for the operations, it's pretty small. No upstream services because this is a client-facing service. Add service, it's a lift service, and it's not that important. We should not investigate it right now. But what could be the problem here? So, okay. Alrighty. So let me jump into Kubernetes because maybe there's an infrastructure problem right now. So, okay. I don't have to remember the pod name. I can just jump directly into it. And, oh, sheesh.
Oh,
okay.
yikes.
500. Okay. And this is in 1 hour. This is not good. What can be the problem? Oh, okay. So apparently it's an easy one to fix. Apparently the liveness probe fails, and most probably the Kubernetes the Kubernetes controller, it's actually trying to restart this a lot of time. And for this one, I'm gonna call Jerry. But hey, I'm gonna declare an incident meanwhile. And now that I took out my phone, do you want to take a do you want to take a selfie?
Oh, that's a good idea.
Okay, let's take a selfie.
Y'all ready to be in our selfie? Come on.
Alrighty. Up. Lights. Okay, there you go. Alrighty. So, Tom and Jerry, I think they're gonna fix this pretty fast.
Yeah, Tom and Jerry are pretty effective.
Okay, so I'm gonna declare the incident, and can you take it from here, please?
Yeah, while you're working on that, thanks, Bogdan. So let's go on to back into the presentation mode. Thank you. What we also want to talk about today is Grafana Beyla. So as we introduced in the keynote, we are announcing Grafana Beyla in general availability today. The public preview was in September, and we've gotten a lot of feedback from y'all, and we're ready to present the first version. So this is open source. It's licensed in Apache License v2. This is emitting open telemetry protocol. That means it's vendor neutral. Because it's eBPF, that means it requires zero code on your part in order to use it. And this is especially interesting for C++ and for Go projects, or if you have something that you can't instrument because you don't have the code anymore, or because maybe you've got some mixed version SDKs that make it impossible to use the OpenTelemetry SDKs. A little bit of an explanation. Not everybody knows what eBPF is. I get to tell you about it today, at least a fast, high-level overview. eBPF is a technology that allows any privileged process to safely load probes in the Linux kernel. So these probes are triggered after certain events that are specified by the probes themselves. For example, if a function is invoked in the instrument application, it can be decorated with a user probe. If a function at the kernel API is called, it can be decorated using a kernel probe. Probes can read or modify the memory of the application that they're observing. And the eBPF also provides communication mechanisms so that those probes can pull that data back out into a user space program. And the user space program can then take those observed events, make more sense out of them, and then send that data to Grafana Cloud in the OpenTelemetry format. So for example, Beyla loads multiple probes in different parts of the system, in application functions, in the application runtime, in the Linux kernel TCP/IP stack, as well as some libraries like OpenSSL. Those probes report basic events to Beyla. For example, the HTTP service being invoked, its start and end time, the status code, the request, patch, and etc. And Beyla takes all of this information, aggregates it, decorates it with any relevant metadata, some of it drawn from the configuration that I'm about to show you, and then it reports it as spans and metrics. So this time we're going to do the demo as a recording because there is a longer pause in the middle of the demo. So this application is made up of 3 services: a front-end service calling a back-end service with HTTP, and a back-end service calling a worker service with gRPC. It is uninstrumented, so we're going to instrument it here with Beyla. First, we need to write a configuration. We can group the URLs based on patterns, and we can also create a regular expression to match with the specific services that we want to instrument here, put them together in a namespace, and also create other namespaces. So for example, here we've got a test load generator in its own namespace. Beyla can be deployed as a daemon set or as a sidecar. To match multiple services, we need to deploy it as a daemon set with admin privileges. So we set up those admin privileges right here, right there. We also need to set it up to send the data into Grafana Cloud. So we need to give it the name of the cloud zone that we're sending it to, the stack ID, and also the API key. All of that is set here. Once we have that configuration, all we need is one line that we can then call, and then it immediately starts sending data into Grafana Cloud. But it takes a little while for that data to arrive. Once the data has arrived, then we can look at these services in the application observability plugin. So here you see the back end, the front end, that little test load generator, and the worker. You can also see, in this case, we've got, it's an example program, we've got it deliberately sending errors. So you can see an example of errors. You can see the red metrics, rate, error, and duration. And you can also dig into the traces. And you can see that we are able to instrument both the HTTP calls and also the gRPC calls. All of that with just that one single command line. You haven't had to change any of your code in order to do this. So we've announced application observability, and we have announced Beyla. Thank you all.